Let's go over how to use a payoff matrix to analyze the optimal strategy for a single round of the game Cancer Fraud. How this game works, if you've never played, is there are two players. One player claims to have cancer, and the other player bets on whether or not that claim is true, which, if player one is being truthful, he can prove that in fact he does have cancer. If player one is not being truthful, then he cannot prove that he has cancer, and hence he can't win the money that was bet on that proof. So here we see the choices for player one in this game. They can prove their cancer diagnosis, or they can not prove their cancer diagnosis. Of course, if they don't actually have cancer, then not proving the diagnosis is the only option. As for player two, they can bet $80,000 against player one being able to show proof, or they cannot bet $80,000 against player one being able to show proof. Now let's consider the outcomes and how much each player earns depending on the choices made. If player one is able to prove their cancer diagnosis, and player two has bet $80,000 against such proof, then player one will make $80,000, and so we will write that in red as that favors player one. 80,000. On the other hand, if player one does prove their diagnosis, but player two does not bet $80,000 against the proof, then nobody makes anything. Player two didn't bet any money, so they don't lose any money, and hence there's no money for player one to win. But at least they've proven their honesty. The other situations are similar, because remember, the only money being put on the table is from player two betting that player one is not going to be able to prove their cancer diagnosis. So if player one is not able to prove their diagnosis, and player two has bet $80,000 against proof, well, in this case, nobody makes anything. Similarly, if player 2 does not prove their diagnosis and player 2 doesn't bet anything. Again, no money is won in this case. As we can see, the payoff matrix for a round of cancer fraud is pretty straightforward, and the optimal strategy for player 1 is clear. They should prove their diagnosis, in which case they'll make $80,000 if player 2 bet against the proof, and they won't lose anything if player 2 doesn't bet against the proof. Of course, if player 1 doesn't actually have cancer, then they will not be able to prove their diagnosis, and so only row 2 is available to them. Although this appears to be nothing gained and nothing lost, it would be a loss of integrity for player 1. However, if you have none to lose in the first place, it's clear there's nothing to lose by playing a round of this simple game. Let me know in the comments if you have any questions, and be sure to subscribe for more of the swankiest math videos on the internet. Thanks for watching.
If I was bored, I would rather be unborn than be snoring at the sound of the horn. I was trying to perform, but when they clap I feel the eye of the storm. Cause it's the thunderous sound that drove me far away from my home. Glad I'm not on my own, I'm glad I'm not on my own. And blood after